Okay, I think we're recording now. So I'm going to start up Xquartz again for my machine. So that's going to fire up. For those of you who are on a PC, it's Cygwin, Xcygwin. It'll start up a server. It's a little more involved, but we went over that last class when I remote desktop into my machine, and you saw how I did that. I can go through that again if necessary. But on a Mac, we start up Xquartz, and it's taking a while. But typically, what you get is the terminal to show up. If not, you can always start it up over here. Just to give you, if those of you haven't downloaded Prefs, Magic Prefs, I'll go ahead and just show you that and show you some of the things that you can do with regard to emulating middle mouse, left click, right click, middle click. All right, so this is using a one of these one button mice. You can configure that so that you can do some of the things that I talked about, which is to control the size, for instance, of this window. All right. So there's a question about regarding paths. So whenever you type any Unix command, there is a variable called path. All right. And whenever you type that, what it'll try to do is it'll try to look for the command that you typed in any of these directories, so that if it doesn't find it, or it'll execute the first one that it finds. If it doesn't find it, you'll get something that says command not found. All right. So the path is typically defined in two places. If you're using Bash, which we are here on the machine, you have what's known as the dot profile or dot profile. Right. And just as an aside, any Unix files that start with a period are what are known as hidden files. In other words, if you do an ls on a file where any files that have a period, starting period, it will not show up unless you give the -a option. All right. So I don't have that, but another command, file that you will use is the bash rc. That one should exist. Okay, I don't have that either, but these are the areas where you would define the locations of your paths. Okay. So let's, for example, if we look at this one, echo $path. Right. So let's just, for the sake of argument, that I have a command in my home directory. Let's call it. Let's go into my. This is my home directory. Let's create a file called hello. Okay. In that is we're going to create this as a shell. And all I'm going to do with this is echo hello. Okay. Sorry for the aside, but I wanted to create a command that that you can use. So this won't actually work because the permissions do not allow it to execute. If I try to execute it, it'll say permission denied. In order for this to work, you have to change the permissions. And what we're going to do is going to let the user, you, give it an execute permission. Okay. Now if I say .hello, it'll actually execute that. So it's a shell. That's a very simple shell script. Now, if you look at that, I had to put .hello. I couldn't have just said hello. Right? It says command not found. Why is that? It's because if we look at the path, nowhere in this path does it tell you to go to the current working directory. The current working directory is indicated by the period. So that's why if I say /hello, it'll work. But if I just say hello, it won't work because it went through this entire set of paths here in these sets of directories, right? And it did not find that in the list. So let's actually include the current working directory into the list. And the way you do that is to redefine the path variable. And the way that's done in the bash is the following: path equals $path. So path is the variable. $path means take this variable name and expand on it. Okay. And then I'm going to add, as you can see, all the directories are delineated by colons. And all I have to do now is to say period there. Okay. If I say echo $path, we'll now notice that, although it's hard to see, is that the period now is at the end of that list of directories. So now I can just say hello. Okay. Before it wouldn't allow us to do that because it wasn't in the path variable. Okay. And that's what's happening in your situation, is that you have to basically put that modification of the path variable in your .bashrc file. Okay. I didn't have mine set up because this isn't my account. This is just a Tring account, and they try to keep things pretty Spartan with regard to that. So that's what you'll have to do in order for you to just type xterm, for instance, is to put it in that path variable. So, okay. So yeah, this is typically where a lot of people run into, who haven't used Unix before, run into a lot of problems. Whenever you see a command not found, it's probably because the path variable has not been set up properly, either by the system administrator or by yourself. You kind of have to know where these programs live, so that you can attach the appropriate directories in all those in that path variable. Okay. The unfortunate thing is that there's really no rhyme or reason if in terms of order. And when you type a command, it'll find the first matching file and execute that. So there are potentials for collisions. You know, you might inadvertently run the wrong file, kind of like what I showed in the first class, where we have made a test program, but there was actually a command in Unix called test, and there was some conflict with that. Okay. So very important piece of information, not necessarily image related, but it is sort of inherent with the terms of Unix files. So, okay. So let's go ahead and just review from last time about a couple of things. So I don't think I saved those. I might have saved those files. So I made a. Oh, I have to log into the machine, the system. So just a review, SSH -y. The -y basically allows some of the X Windows protocol to percolate through, all right, so that you can actually control the machine that you're connecting to. So I'm going to go to Tornado this time, but there's also Armstrong, Aldrin, and Collins. Oh, so the first mistake I made here is that I put DIRSIG training. There is no actual user there by that name, so what I have to do is I have to prepend this with the username that I have at Tornado. So and then I type in my password. Okay, here I am. So I created a directory called images, and I put it in netpbm. There's a couple of things here. If you recall, this was an image that we showed that came up with as a bi-level image, and then we have a one that is in ASCII form for gray level, and one that is in raw form. If you recall, these two images that I showed here 42, 52, 62, 72, 82, 92 is the same as this image. Okay. Now the question is, why is that the same? It's because this is actually taking these characters as the appropriate values in terms of these numbers. So if we actually look at an ASCII table, we'll see that in decimal, the number 42 is actually a star. 52 is the number 4. 62 is the greater than. 72 is the H, and then 82 is the R, and then I think that we have 92 there, and then slash. So that's where those things come from. Now recall also that we were able to create a, or I don't think we went through this, but or maybe we did, where we created a the P4 version that displayed this set of patterns. So how does this star 4 greater than HR slash generate this pattern? Well, what we can actually do is revisit the BC command. Okay, and this will actually allow us to convert from a decimal. Okay, so input base equals 10. This is the default. Then I can say output base equals 2. So that from now on, whenever I type in any number that's a decimal, it'll be converted into binary. So let's type 42. And we'll see that it's 10, 10, 10. If we go back up here, if you do it in terms of 8 bits, it's 00, 10, 10, 10. All right. So that's where the first pattern comes from. If we type in 52, it's 110100. If we go back here, it's 00. Whoop, lost track here. That's why people don't use binary. Oh yeah, 00111010, and you can see that it's the same pattern. Okay. So what's happening here is that the actual ASCII value is being interpreted as binary digits. Okay. So that's why you have an image representation that is different, but come up with the same image. Because one's meant for human consumption, and the other one is meant more for computer consumption. Okay. You could have used Wolfram Alpha to look at these values, but I just wanted to show you also that you can use the Unix commands to actually make a conversion. So the calculator can use that in terms of converting it to different pieces. You never know when you might have to use this to change a whole range of numbers in a script. Okay. Wolfram Alpha is great, and the web is great for like onesie twosies. But if you want to generate, you have a whole number and you need to generate a different base on it, you can do that. Okay. Any questions with that? So that's where all those numbers come from. Let's actually go back now and just create the color image, just a review. So I'm going to use Nano just to .ppm, so portable pixel map. And for the human readable form, I can type P3. Let's do a 3x3 image with a maximum value of 255. And let's create a red pixel, a green pixel, and a blue pixel. And let's create the complements of these guys. So 0, 255, 255, 255, 0, 0, 255, and then 255, 255, 0. And then let's create the gray level So 000, 128, 128, and just to illustrate that the format really is more for your benefit, I could just say 255, 255, 255. So I could have formatted this as one big column if I wanted to, but it really doesn't matter. What matters is the metadata that you have for this image, which is the size, the samples, and lines, okay, and the maximum gray value. So let's go ahead and save this out. Oops, Control X, and display it. So we'll use GIMP again really quickly. To open that up. Color.ppm. Can't see it, but let's zoom in on it. There you go. So even though this is of a very small image, the principles are the same. So this is the NetPBM format. So now let's talk a little bit about some of the tools associated with NetPBM. If we actually go to, if you do a Google on NetPBM, the one page that you want to go to is NetPBM homepage is good. And there's a lot of tools associated with it, a lot more than I really want to go through, but I just want to go over a few of them so that you know that you can use it to for instance, change the format. So suppose I wanted to change that particular image that we just created into a TIFF file. There is a way to do that. There's a PNM to TIFF converter. So I can actually go in here, let's get out of GIMP, and I can say PNM to TIFF color.ppm. And this is where a lot of people have to be a little, have to change the way they think about this command, in that what you really need to do is you need to redirect the output into color.tiff. Why is that? It's because in Unix, what you can do is you can start chaining a whole bunch of commands together. So for instance, if I wanted to take a ppm file, right? So this file, and I wanted to scale it up, can't remember if it's a percentage or not, but let's say 100. And then big color dot tiff. Oh, nope, I need to say PNM scale, and then PNM to tiff big color dot tiff. Right? So what is this doing? Well, first we're going to convert the input file into a TIFF file. Oh no, I take that back. This, no, that's not what I want to do. Sorry. Still, well, let's start with this. PNM file color.ppm. Okay. Very simple command. So whenever you have a a file, a PBM, NetPBM file, you can always interrogate it by typing PNM file. Right. If I want to scale this, I would say PNM scale color.ppm. Okay. I think you give the factor here. And if I save that to a new file, big color.ppm, you can see we can check out that file now. And now what we've done is we created a much larger image of this. This is something that we can actually look at. So we can say display big color.ppm. Hopefully, yep. Which is different than what we had before. But we wanted this to be a TIFF file, so you could have created this whole command as the following. I could have said PNM scale, let's make it bigger now, 500 color.ppm, and then PNM to TIFF, and you can say big color 500.tiff. So there's the scale command, there's a crop command, there's a no raw command. So one of the things that you want to look at when you say PNM file, oops, it didn't work because it doesn't exist. So let's go back to the big color. Can we type this out to the screen? What would happen if I typed it out to the screen? Maybe. One thing that we should, I want to point out is that if we do a PNM file on the original image, if you look at it very closely, it says plain, right? This one we can do. We can say, if we say more more color.ppm, not a problem. We can look at it. However, if we did, I'll go ahead and show. If I say big color.ppm, okay, so you really can't see it because a lot of this information is in binary format. And this is how your terminal gets all messed up, because some of these binary information is actually taken as commands to the terminal. So that's why all of a sudden your terminal starts beeping and started changing colors and then going crazy, is because by happenstance some of those patterns, those binary patterns that are being sent through your terminal, are taken as commands to the terminal to draw certain characters, set up certain things. So the question now is, well, how do I actually get that into a form that I can see? Well, if we look at the steps that we did, let's see, where did we do that? We did this one, PNM scale. All right. By default, if it's a big image, it'll try to convert it into a binary. But you do have the option to say, you do have the option to pass it through PNM no raw. Okay. What that will do is it'll make sure that this becomes an ASCII data. So now if I say more big color ASCII to ppm, there you go. So this is actually pretty useful. If you've got a file and you want to, and it's a TIFF file, for instance, you can convert that TIFF file into a PGM or a PPM. It may still be binary, but you can pass it through PNM NORAW to force it into values that you can actually read and manipulate through either a text editor or bring it to Excel, what have you. Okay. The other thing that you can do with these, the PGM commands, is to, there's a PNM hist, or it's like PPM hist. So let's do the other. So we just did a color histogram of this particular image. Not very interesting because there's only very few colors, but it does give you all the counts associated with that. And we'll revisit this to see how we can process this later to do plots of it, for instance. Even though you've got text data here, some of the manipulations that we'll be talking about is how do I actually go in there and start pulling off columns in order that I can plot them. There is no plotting routine that's associated with NetPBM commands or with this command, but there's no reason why you can't take that data and reformat it into a form where you can probably use it in GNU plot, for instance. So just be aware that you can do that. There's also an associated PGM or PGM hist, and we'll do that, apply that to my image.pgm, and it gives you appropriately the counts of the different images. Okay. So those are just, we just touched like 3 commands out of NetPBM. I encourage you to go through, and if there's something that you want, that you need to do that's sort of similar to what you would do interactively in Photoshop, there's probably a command in NetPBM that will allow you to make that kind of manipulation. The other things that most people typically do is split out. Let's actually see if I could remember that. PPM to RGB3. And that allowed you to say more big color dot red. Okay, so you have the red color, green color, blue color. So we can actually display each one of these. Big color dot red. Okay. Green and blue. So another one that, and you can, the command also, there's also a command to allow you to go from separate separate bands, and we combine it into an RGB. So that's NetPBM. So let's actually start working with real images. All right. And I'm going to go to a specific website that has actually a bunch of images, and I'm going to go over some commands in Unix to essentially extract those files. So the one website that we have is this USC, okay, and they have this file. There's a couple of archives that they have called mis.tar.gz and mis.misc.zip. So most of you are probably familiar with a zip format, but on the Unix land there's actually the tar.gz, and we'll talk about what that format happens to represent. So now I could actually just download these guys by just clicking on these things through the web browser, but what I do want you to realize is that you could easily do that from the command line. So let's actually copy one of the, let's go to user temp, User temp is an area on most Unix commands thought of as for temporary space. You can always put stuff there that you don't really care about that will disappear after a while. So that's a good scratch space to work with. Just be careful that you don't fill it up, because other Unix processes actually use that also. Most common problems that will typically happen is that when you run out of disk space, a lot of processes can't write to user temp or var temp as it's known, and because there's no place for it to put the data, things start failing. Right? But in general, if you have a small pieces of information that you want to play with and not necessarily clutter up your account, you can use this area as a place to work with, and that's why it's called user temp, because that's meant for that process. If you create any shell scripts that need to use temporary areas for scratch space, for instance, if you're using like temporary files in your workflow, you can use user temp as a place to dump some temporary files, read from it, and then delete it later. Okay. So we're here. I can actually use the command called wget. And what wget essentially does is it's very much, okay, I just downloaded that. What I really meant to do is I meant to copy the, let's see if it'll let me do that. Copy the actual file name, which I can't because I don't have a 3-button mouse. But, oh, there it is. Let's see, it showed me that to me. Okay. Sippy, let me just type that. So wget http sippy.usc.edu/database. Actually, let's actually go and see what that is. Database mis.tar.gc. So wget is essentially a command line version of clicking on that hot link and downloading it. Particularly useful if you have a whole bunch of files that you just want to download automatically. Okay, instead of you getting on the website and clicking on a link, by knowing the address of that particular file, you could just type that. And likewise, I can just type .zip here, okay, and it's picking up the other one. So wget is the Unix equivalent of clicking on a hot link and downloading it. So there's another command called curl, which does the similar thing. There is a distinction, but I don't know what the distinction is. So zip file, you're probably familiar with. That's your classic Windows zip. There is an unzip command in Unix land, which will work on that. But the other file that you might see is the tar.gz. All right. And that's actually the product of two processes in Unix. One is known as a tar file, which is a tape archive, way back when files were essentially conglomerated into one unit called a tape archive. Right? And GZ is a compression. So what you have here is a compressed tar file. So there's two steps that you can do to process this file. You can do an gunzip. So in this case, we'll have misc.tar.gz. And what should happen here is that file should disappear, and what you should have now is just a mis.tar. So it's a tape archive. Okay. And to put that into a directory, you would say tar xvf misc.tar. Again, I'm just showing this to you so that not necessarily to know all the options, but realize that, oh, wait a minute, if it's a gzip tar file, these are the commands that I need to do in order to extract that. So let's actually do that. And it creates a file called MISC. So if I cd into MISC and do an ls, those are all your files. Did you do it on a user temp? Were you on user temp, or were you in a directory that you don't? Okay. Try to do it in your home directory. Okay. Yeah. Sometimes Vart. Yeah. It depends on the. Sometimes user temp is not a good place if the system administrator doesn't want you to dump too much stuff in there. I actually logged into Tornado. You're probably on Armstrong? Yeah. Okay. Armstrong may have a different set of permissions. So if you want, I can wait a few minutes. Yeah. You're fine? Okay. Right. So we have all these images. And we can, you can display each one of them. But often what you want to do is just sort of create a browse of this image, of this set of direct files. Okay, they're all TIFF files. We already talked about how you can convert that into a NetPBM image, but here's a little trick that you want to hold in the back of your hand called display, and there's actually a format in ImageMagick. Question is, okay, how's ImageMagick related to NetPBM? They're really not related. NetPBM is an older set of tools that preceded ImageMagick, but then another group said, okay, we could do better than NetPBM. Let's create ImageMagick. And ImageMagick essentially does a lot of the things that NetPBM does, but a lot more tools in it and a lot more capabilities. One of the more useful ones that I've found is the ability to create what's known as a visual directory. So I can do the following. We can say vid : which means create a visual directory of all the TIFF files in here, as indicated by the star.tiff there. And if I do this properly, if I didn't mess up the syntax, I get a visual directory. What's really cool about this is that you have all the information associated with all these individual images. But not only that, there is actually some metadata that tells it how to access those files. So for instance, if I wanted to click on the mandrill, for instance, and I don't have a 3-button, I'm going to steal the 3-button mouse from here. Oh no, is there one here? Yes, it is. Bad. That's why I always say invest in a good 3-button mouse. Is that I can say load, and you can go directly to that particular image, and you can say former, go back to the directory, the visual directory, and then click on another one, load that one. So not only do you have a very small an overview of the images in your directory, you have the ability to interrogate each of those images. Okay. So it's one of those useful pieces of it. One of those useful little tricks that you have, particularly if you've got images that are typically just ones that you know, common images. We will talk about more non-common images when we start going over some images that go beyond red, green, and blue, and are not necessarily limited to 0 to 255 values. Right? So You can click on each one of these, load, and you can also, let me see if I remember this. Again, I don't use the GUI that much, but you can try and look for the information, image info, right? So this gives you a whole bunch of information, more than you really care to know about the image, okay, the resolution. But you can also get this kind of information at the command line. So I can actually go back here now and exit ImageMagick display. I think I have to dismiss this. And I could do identify. Okay. So that gives you the dimensions. If I said identify star.tiff, you have all that information associated with each one of those files. And then if you want something a little more, you can say identify verbose house.tiff. Right. So that is similar to what we saw on the original screen, where you have all the properties. You have a signature associated with that. So sometimes the signature is actually very useful, because this will tell you whether or not that particular file might have been modified. Okay? You modify a single pixel in this image, that signature will change. Okay? This is what's known as also a checksum, some form of checksum, similar to a checksum, which basically just creates a signature associated with this particular image. There is also a couple of concepts here called endian, which we'll talk about later. But endian is one of those critical pieces of information that you have to understand, particularly if you're dealing with data that's multi-byte. In other words, each pixel or each pixel of data is greater than 8 bits, maybe 16-bit or 12 bits, 14 bits, 16 bits. It's very critical to know whether it's what its endian is, MSB or LSB. Okay. And we'll talk about what that means. So a lot of information here that you can extract from this file. Right? Very much similar to the PNM file command that we just talked about. Any questions with this data set? So I already showed you identify. What do we want to do? Let's. What do you guys want to do now with all these images? What do you? If we kind of showed you how to look at it. Now ask me. Well, this is what I want to do next. Put them all in one big file? Well, how? Yeah, they're all different files. They're all TIFF files, but they're all different sizes. Okay. But that's actually a good one. Let's actually try that. So one thing that I can, and this will actually lead to some other problems, but I can actually go do the following. I can say convert star.tiff to one big file dot GIF. Okay. GIF is an old format that allows you to do a little bit of animation. So this used to be something obscure until very recently. Now everybody's got animated GIFs, and you can actually do this, and it will illustrate a couple of problems. But let's go ahead and do that. Because when you say combine one big file, well, there's many ways of there's that's sort of an ambiguous statement, but let's go ahead and do it. So So we know that we can display each of those images. Right? We know that we can say display house.tiff, okay, and we get this. But what we just did is we created an animated GIF. So in order for us to look at that, I would say something like animate, what I call, one big file.gif. And it does work to some degree. One of the problems that you can see is that some of those images are cut up because it keyed off of the very first images. Now I know a solution for this, but I can try to do it on the fly, and it'll probably mess up really bad. But I could try to see if we can solve that problem. But this is actually a good way if you've got a whole bunch of images that you want to sort of animate. This is a quick way of doing that. If you have a whole bunch of TIFF files, you just use the convert command in ImageMagick and just plop everything in there. But as you can see, if you've got images with different sizes, it really doesn't work very well. And I'm going to see if I can remember how to fix this, which is probably going to use some trickery that is going to kill everything. And let's do identify star.tiff. All right. So we can see that these, we want to sort by this column. So let's see if we can sort this set Ooh, did we? Not quite. All right, let me think about that one. But I think I know how to do it, but I just need to get the syntax properly. So remind me to we'll come and revisit how do you actually recombine this in such a way that you go from the largest image to the smallest image. There's a way of doing that. I just can't remember all the syntax associated with it, and I'll probably waste a lot more time than I need to do that. But animate, let's just say so. One of the things you can also give to animate is to put a delay on there. So I can delay 100 and then 1. Particularly useful if you're going to try to create an animation that people can actually see. You can see that it's going to take a while. It'll pause at each one of those. Right. And now what you may want to do is you want to say, well, you know, I actually want to create an MPEG file of this. Right? I don't want it to be a GIF file because a GIF file can get very big. I want it to be an MP4 file. Well, you can do that also, including the delay, by simply saying animate minus delay 100 one big file.gif to one big file.mp4. So if you've got a properly installed ImageMagick, oops, not animate but convert, sorry, that's a good okay, so you don't need there's no guarantees on what the quality is of the conversion to MP4, because if you're familiar with that suite of tools, FFmpeg, there's a whole bunch of parameters that you can tweak to do that. but you can also see that it's a much smaller file than the GIF file. Okay. So there will be artifacts with that. If we actually try to look at that, we'll probably notice some artifacts, interpolation artifacts due to the encoding scheme. So if I said animate one big file.mp4, I don't know how obvious it is in this case whether it will show up, but you will see some blocking artifacts, the encoding artifacts. Yes?
I didn't understand. Is this a video here? Is it MP4?
MP4 is a video format. So it's basically a digital video format that like Apple and I can't remember the name of the original company, but this is how a lot of the video is being distributed these days. Is through an MP4 format. H.264 is what they call it. The GIF format is just a graphics format. It's basically a stack of images, and what the MP4 format is just a stack of images, but there's a lot of compression that goes through. So what it does, it goes through a lot of interpolation to minimize the amount of information that's being transferred. And that's why you can look at this one. You can see that it's almost an order of magnitude much smaller than the GIF file. GIF file is just a stack of images, but MP4 sort of does interpolation between each of the frames and encodes it in a way that it's getting rid of redundant information. So it's hard to see here, but what you'll see is that if you look at it a little more closely, you will see probably some blocking artifacts associated with the compression through MP4. I don't know why it's not running it kind of on the slow side. Is that working properly? I don't know. Anyway, let's see what else. So ImageMagick also convert one format to another very seamlessly. A whole going on with this one. I have to look at this a little more closely. Why it should be creating something. It should be moving. It didn't play. Oh, did it play? Okay, all right. Oh, there you go. Yeah, there you go. Because one of the things that I think it had to do is it had to actually take the MP4 file and then quote unquote uncompress it, but because it's not really. There are ways of encoding MP4, so that's either you bring it down as one big piece, or you can stream it, and it all depends on how you actually do that. So this just is yet another tool if you have a bunch of frames that you want to create into a quick file that you can slog around. GIF file would be great, but as you can see, it's fairly large because it's essentially the full res image. But MP4 will go through and try to remove some of the redundancies associated with interframe correlations. In this case, this is actually a bad example because a lot of those images are not really correlated very well. You just happen to pick out a whole bunch of images that you can display there. So let's now move to some information on how we actually process some of the metadata associated with images. Okay, we kind of know how to work with the images, but suppose we wanted to now, well, let's go through a conversion process. So we want to convert each of these files to no, let's jumping ahead. Gotta stay focused. All right. Sorry. So quotes. In Unix, there are 3 types of quotes, and each of those quotes have different behaviors. And knowing what the behavior does will either mess you up or will help you do some really cool stuff. So let's start with couple of things. So if I say A equals LS, okay. If I say echo $A, get LS. If I say B equals, what do I want to do here? Oh, $A, what do we expect? LS. If I say B equals $A, in quotes, what do we get? LS again. But now if I say B equals $A, what do I get? Okay. So the thing that you need to understand is that double quotes allow what is known as variable substitution. It was able to go into $A and say, oh, this is actually a variable. I'm going to resolve what this variable is and assign that value to B. However, if I put single quotes there, single quotes means protect whatever is around the single quotes so that you take it literally. Okay. But now here's the more powerful case. If I say B equals $A, what do we think what's gonna be the answer? Any guesses? Like, wah, what's going on here? What actually happened here is that those backticks tells it to run whatever command is in there. Okay. If we resolve what $A is, $A contains the command ls. So what's happening here is now you have a variable that contains the output of the ls command. Right. So those are the things, those are the key things. So this is very powerful because now you have a way to actually execute commands and get the information stuffed into a variable. Right? And you can actually go and interrogate each one of these variables. So you can say for I in $B, I can say do echo $I, done. So you actually have a way of going through each of those file names and processing it. So now if I wanted to say not just echo $I, but do something like identify $I, you're now able to actually go through each of those files and apply whatever command, whatever Unix command you can think of. Okay, that for loop that we just created will go through each of those variables in $B, pull each one out, and then process that. So let's go back at the form of that. Okay, this is a very important step right here where you can just echo it, because you can now say something like echo PNM to TIFF $I to $I dot PGM, let's call it PNM. So one thing I didn't tell you about is that PNM is basically a placeholder that says I'm either a PGM, a PBM, or a PPM. Okay. So we're just echoing this right now, but as you can see here, what this will do is it will actually, if I didn't just echo it, but actually executed it, I should be able to create a whole bunch of NetPBM files. I can convert that entire directory into a bunch of NetPBM files. So let's actually do that. And I always tell people to do echo first before you do that, and also make a backup of the directory, because not only is Unix powerful in terms of being useful, it's also powerful in terms of being destructive. It only takes one command to erase your entire home directory, and that is the drawback of having something very powerful. As Scott Brown says, it's kind of like having a chainsaw. A chainsaw is great if you know how to use it, but you can also cut your arms off with it. So let's see, and that's where an echo command is actually helpful, because, oops, wait a minute, what did I do wrong? Oh, I forgot to take out that, let's actually do this. Echo I am processing $I. Oop. Sorry, went the wrong way. TIFF to P. Okay. So now we have these PNM files. So if we did PNM file, let's actually go through this. We can say A equals single quote ls star.pnm. Just to repeat that, echo $A, you've got all the PNM files now. So you can say for I in $A, then do PNM file $I, echo $I, done. Okay. So you have all this information now that you can apply. You know what the dimensions are for each of those PGM files. You can actually process that. You can actually take each of those elements and try to use that, for instance, for you can process that information. Okay. Any questions so far with this? So the for loop, that for construct that you have there in Bash, is very powerful. It allows you to go through each one of those files, and then you can put whatever command that you have there, and then you can actually process that information. Now, the question here is, how do we actually pull out all this individual information? You've got this string now. How would you do that? Well, you can do the following. You can say image info is equal to PNM file, and let's just take a specific file. We remember house.tiff.pnm. What does that do? Well, it puts into a shell variable that information. Okay. Those are actual pieces of information. Can we go through each one of those? I'm not sure, but we can try. For I in $image info, do echo $I. Sure enough, you can actually individually pull out each of those elements and actually use it for calculation. Now, how do we individually pull it out? I can't remember. But this will actually bring up another tool. There's many ways of extracting out the information. Like, for instance, you want to pull out the length or the you want to find out the samples versus lines. Okay, how do we pull that information out? There is a way of doing it in the shell script. I can't remember the syntax, but what I do want to introduce is a different tool. Okay, the one that that's very useful is awk, or gawk is another name for it. It stands for Aho, awk, Weinberger and Kernahan, and it's just a very small tool that does very, very simple things. It's great for large files because it'll allow you to modify a bunch of files in column data into a very quickly. Right? So awk is basically a processing system. And the way awk works is that it'll actually read in a file and essentially go through and break it up into columns. So, in fact, let's actually save this. Here's a question. If I did this, it goes up to the screen, but suppose I want to save it all into a file. Let's see, can I do this? You can actually do the following. All right. What is this doing? It's actually going to take the output of PNM file and repeatedly insert it into this file called mydata.txt. So we've seen the greater than used before, in that we can redirect data that's coming out of a command into a file. However, we haven't seen this double greater than. And what double greater than basically means is that you will append to the existing file. Right? So before I actually execute this command, let my data.txt. Okay, there's no such file or directory. However, if I do this, okay, we will see that my data.txt will contain all the information associated with that command executed many times. Yes?
The echo $I will print out the number 1, 2, 3, 4, 5, 6.
No, it'll print out the file names, not 1, 2, 3, 4, 5, 6. Do not think of the for loop as having a numeric piece of information. That for loop will basically take, if we go back here and we say for I in $A, okay, what it'll do is it'll take whatever is in $A and assign that into I. Okay. If I say echo $I in this case, oops, do There is no 1, 2, 3. It's a. I understand where you're coming from. If you've programmed in something like C or C++, you typically think of a for loop associated with an index number. In this case, there is no such concept of an index number, but what you're doing is you're just taking each element of the array that you're referring to and assigning that to that variable.
Can you print an I out? The print statement?
Well, we did that using the echo command.
Oh.
Okay. Yep. Think of echo as the print equivalent in Unix. So we have this file, mydata.txt. And what awk basically does is it'll take an existing file and just print out columns if you specify it, okay? So I can actually just say awk, gawk, and I say I want to print, if I want to print all the entire line, I just put a $0 here. Okay. Now this $0 is entirely an awk. Oops, I have to give the file name. My data. Not too impressive, but if I want to print out the first column, second column, okay. Just the first, third column, okay. Fourth column. If I just wanted to say print out the $1, fourth column, and the fifth column, whatever the fifth column might be, let's make it the sixth column actually. It's a very quick way to do that, okay? If you had to do this in a programming language, you'd have to go through the whole process of opening up the file, reading in each line, figuring out what piece needs to be pulled out. In awk, that process is already inherent in the way it works. It knows that you're giving it a file. It knows that you want to go through each of those lines. It just simplifies how you extract each of those pieces. Okay. And again, I can go and go up another level and say my columns equals so what you just did there is you took that command and basically shoved all that output yet into another variable. So you can go through all these different levels of instantiation to address almost any kind of problem that you're running into. Okay, but that awk command, very, very useful, very helpful. If you have, let's say, a bunch of spectra, for instance, that you want to convert from one value to another, that's a one-liner. Okay, that's one line of information, one line of an awk command that says take some value, multiply it by some number, and output it into a new file. Right? Some people would actually try to use Excel to do that, which Excel typically has a limit on the number of rows you can do, and awk doesn't care. You can have a 1 million line text file, and it will process that without any issues. And that command is only one line. Very, very powerful. So awk is something that I'm introducing to you. There are so many pieces in it that, as with all the other tools I've introduced, I'm just touching on a very superficial capability of that tool. But awk is something that you want to study in the future should you find yourself in a problem where you're dealing with metadata that needs to be converted in somehow, some way. Okay, it's great for like extracting elements out of a given file. Okay. It's also very useful for just picking out one specific piece of information, and I'm just reminded of that, and I'll try to pull that example from for next class, where you can have a 40-page output and be able to extract a piece of information with like one line. And this is something that we actually had to do in the past for one of our research projects. We had this 40-page output of a bunch of numbers, but there was only 2 elements in there that we wanted to be able to extract. And awk basically allowed us to do that, using a couple of lines of code. And when we had no idea how big this file was going to be, but we knew that there were certain patterns within that file that basically told us that the next few numbers will be the numbers that we want. So you really didn't have to know anything about the format of that. Any questions with that? We'll sort of hold off on that and look at the awk in more complex situations. But whenever you have to process a lot of text data, column data that you want to work with, you can do that. I'm seeing something here that might be helpful to see that I'll introduce later. So if we just wanted to print out okay. So this is the output from that file. What's the problem with this information if you wanted to use this? So we know that we can extract each of those file names. What's the problem with the file name? Not so much two format names, but what will cause it to where you can't use it in a MATLAB program, for instance? That's right. There's a colon there. How do we get rid of that? So, good question. But there is in Unix a way to do that. You can do what's known as a tr minus d, and then the tr is a translate. It's a character translate. You can actually tell it to delete a specific file, a specific character. And there you go. Just got rid of that. Okay. I could have replaced that with something else. So if I wanted to, for instance, create a, I want to substitute that with a comma. You could do that. tr is a command that translates one character to another. Very useful if you happen to want to create a CSV files, for instance, comma-separated values, and all you have are spaces. Okay, there's a way to actually take that and just one command convert every space that you have in that file into commas. Okay. Again, kind of trivial stuff, but if you've never seen this before, you'll be, some people would actually go in and try to use an editor to do that. And we'll actually touch a little bit on sed, which is, usually when you hear people talk about awk, they also talk about sed, which is the stream editor, which works in a different way. There are some wacky things about it. And if you learn VI and you get very proficient at VI, a lot of the syntaxes will be quote unquote familiar in sed, and we'll see that Probably in the next class, we'll talk a little bit about SED. Although we talk about images, I think part of the things that you really need to do is actually work with the metadata associated with the images, because often that's something that you need to hold on to and somehow use that as part of your process. Okay, if you're convolving something or you're cutting up an image into multiple sub-images, you kind of have to know the original size of it and what size you want it to cut up, for instance. So there's a lot of pieces there. All right. So that was just a side. We'll see TR again. That's something that I use quite a bit also when I'm processing metadata. All right. So let's skip back now to the question that Colin asked about, and that is using, when you use X Windows, for instance, it's okay in an environment such as here on campus, where you've got very fast bandwidth. However, if you try to do that at home, for instance, where you don't have as high a bandwidth as you do here at school, trying to start something like Envy, for instance, where it will try to display this to your on your machine, that could be a very slow process. In fact, if you live off campus, I encourage you to connect to the RIT CIS servers and just start up Envy, like I did right now. Envy minus Classic, it'll take quite a while. And Colin sort of saw this with what was the name? Photoscan, yes. In fact, you know what the command was for Photoscan? I was just curious.
I just
but now you know how to make it to do that. Okay, so and the reason it's slow is that you're actually telling these two computers, your laptop and the CIS server, are actually talking to each other and saying and giving it commands. It's like, oh, this is how you draw this character. This is how you draw the graphics. So they're talking in terms of actual commands that your machine will interpret to actually draw things. Well, there is a way to actually bypass that chatter, and that is through what is known as VNC, Virtual Network Computing. And what VNC basically does is it'll create a desktop, a virtual desktop within the Unix system, within Armstrong, within Tornado, within Collins, within the machine that you logged into. And so what's going to happen is you're going to actually create a desktop that you will now connect to. Okay, so the command that you need to do for that is VNC server. Okay, and then what you have to do is you have to choose a number. Unfortunately, it doesn't do it automatically. 2-digit number, pick one. If it already exists, if somebody's already using that number, then you run into a situation where that person's going to, or you're not going to be able to use that specific type of window. So let's create one, and let's say 13. Right. And there are options associated with that. So now we digress now to a couple of things that we need to set up. You've just created a virtual window. In order for you to connect to it, you have to specify a weak password. So I'm going to come up with there's a VNC PASSWD to create a very, very weak password, but I'm just going to create one just for this example, so that you can actually access this, and I will call it, let's see, somebody give me a easy to remember password. I'll change it right after this. This is just for demo purposes. Password, I like that word. Okay. Would you like this to be a view-only password? I'll say no. Okay. So, what I've just done is created this window that exists in Tornado, that space, with the :13. So, if you wanted to access that particular window, you can actually do that. You can actually, if you log into, or if you download one of the what do you call that, viewers, you can actually access that. So, as an example, I will, on a Mac, you can actually connect to that using Go, and then connect to server, and I can say Tornado 13, connect, and we gave it password. And there is my window. If you guys connect to it also, you could probably move the mouse also if you followed what I just did. If you have a Mac. Oh, okay. So on a Mac, you would say Go, connect to server, and give it that. So it's always 59, and then the ID, the number, the desktop number. So it's VNC. Let's go do that again. This is sort of the quick way of doing that without downloading anything. So VNC / Tornado CIS. Oh, so you're connecting it. Khan's already connected, so he's actually. So this is what I started, but you can actually go ahead and do things on there. So I don't know, Startup Envy type or. So he's actually controlling this this machine right that desktop right now. My hands are up here. See.
My screen doesn't show it as fast. Like when I see Envy.
Yeah, you see it up there. But this is the reason this is a little faster is that what it'll do is it'll actually not send commands to draw things. It'll just send the images, the pixels that are changing to your machine. So it'll be a lot more responsive because all it's doing is sending all the pixels that are being changed rather than telling your computer to actually go through a process of actually drawing the graphics to do that. So.
On my screen, it still doesn't show anything.
Okay, yeah, that'll. I don't know why that's why it's taking a while to do that. It's kind of weird. Yeah, it is. It's kind of crazy. But sometimes that method is not very useful. What you want to do is use something like real VNC and tight VNC. Those are what's known as viewers. Okay, those viewers will actually talk to this server, okay, and allow you to modify that. The problem with this method is that it's really not very secure. There are no, once the password is sort of encrypted, but the traffic that is actually happening right now is unencrypted. And I've been trying to push the center to actually come up with the licensing to actually allow you to do that in a more secure method. So this will still be slow, but I think you'll find that it's a little more usable in terms of being able to work with that. What's that?
When I read showing
much.
I don't know why I wasn't the first.
Okay, so I handed out to you actually my slides. I actually tried, I think I found the file, but I'll just read through it so that you guys can. So VNC, virtual network computing. So there's a couple of implementations, the tight VNC and real VNC. Now these are actual programs that you would download, all right? And you would start up the server like we just did here. So tight VNC and real VNC are two programs. They're both the same, they're kind of the same. They're just implemented by two different groups, right? And you can connect to it. What's really nice about having a VNC session is that these things don't typically die. The sessions here don't typically die. So if you're in the middle of a process and you've got a whole bunch of windows open and you get disconnected, you can connect again and it's still in the same state that you had before. So you can actually, do some work here, go to the library, connect to this server, and your mouse should be in the same location that you left it. If you did via regular X Windows, if you have a problem with the network connection, all your things are gone. Once you start that up. This one, however, will maintain all those. So, and as you can see, there's a little bit of collaboration. I'm actually making the movements now. Colin can take over if you wanted to. But what's that?
I put the connection.
Oh, you put the connection. Okay, yeah. So those of you who want to try to connect to that, it's you can download tight VNC and real VNC and try to modify that. I would recommend that you create your own desktop for that. Now, how do you actually kill this? Well, what you would have to do is to give the following command: VNC server -kill :13.
Is this like remote desktop connection of ratings?
Yes, that's one way of looking at it. Yep. It's kind of like remote desktop protocol. Now, I'm not going to do this now because I want to actually go over another command which will allow you to sort of see what's running on the machine. So typically you can have the what's known as the top command. And top will sort of tell you what the processes are running. The other command that you can, this sort of shows you interactively what people are running. The other command is the PS. Okay. Now that was a lot of information, but you can pipe this through a command called grep. And if I type VNC, you'll see all the people who are running VNC. So and if I wanted to narrow that down a little more, like I said, grep VNC, grep RVRPCI, and how come that didn't show up? What's that?
Throughout the C.
Oh, yeah. Stupid computer. So there you go. So another command that's very useful that I use all the time is called grep. What grep simply does is it actually looks for a pattern and extract those lines that have that matching pattern. So what I've done here is I grepped for a command, and then I grepped one specific for my username. And you can put whatever pattern you have in that situation there. Use the grep commands there. VNC. So this is actually will tell you what the VNC processes are. What who has colon 42, 43. So there's colon 13. So this is the process number of that command. But the proper way to actually kill it is to say VNC server -kill :13. And likewise, you can find out who has a particular number. And this should disappear. And as you can see, this thing just died. So VNC server minus kill. What people will probably run into is that they'll start a lot of VNC server sessions, and you don't have to do that. You don't have to do that once, and then it'll stay in place for a long time until you kill it, or until the system gets rebooted. So those sessions will disappear. The reason I showed you also the PS command is sometimes this will not work, where the VNC server minus kill will not work. And what you have to do is you have to actually give the kill command, giving this process IDs. The second numbers are the process IDs. Right? So whenever Unix starts anything, it assigns what's known as a process ID, and that is how you actually kill a process. Okay? You would say kill, and then give the process, which is what VNC server actually does, but it also does a lot of cleanup associated with that command. So, anything else about VNC that you guys should be aware of? There's.
I have a failure of connection to
Oh.
the VNC.
Oh, the one I just killed?
No.
Oh.
But I think I created one,
Uh-huh.
and then it says make sure screen sharing or remote management is enabled on the remote computer.
Okay, so which computer did you start up?
It was Armstrong.
Armstrong? Armstrong.cis.rit.edu? What number did you use for creating it?
So,
4. Okay, so now when you connect, how did you connect? You have to say colon 5904. Yes, so the way VNC works is that it goes through what's known as a series of ports. Okay, 5900. Right. 5900 all the way up are a bunch of ports that VNC talks to in order for you to access that. And so that's why, as you say 5904, anything that says 5900. In theory, also, you can actually use a web browser to connect to a VNC session. I've done that in the past. You have to give it the number 5800. So in the example that I just killed, you would say 5813. Okay, and then sometimes you can actually access that. That was very useful back when systems were not as agile as they are now. It's been a while since I've done that, but it is possible to actually VNC from a web browser. Nowadays, that's really sort of a moot point to do. Just be aware. Were you successful?
I need to create a password.
You have a create a password. And then you should do it. But this is actually a way for you to use VNC is the way to be able to use some of the more powerful graphics-intensive systems. So if you have a MATLAB script, for instance, that you want to see, moving graphics around, a VNC session is probably the more likely thing to do if you're going to do it from outside of RIT. Within RIT, it's okay because the bandwidth is fast enough. But in most home networks, there's the asymmetric problem of your download speeds are not necessarily similar to your upload speeds. That's why you sometimes run into those issues. And also, it's much, much slower.
So if I have home driving my phone, I should do it this way?
Yes, you should do it this way. It's a much easier way. The other thing, why you may not have, she's not showing a particular window manager is that there's a file which I forgot to talk about. Called xstartup. And this is something that you probably want to copy from my directory. So you can copy, so you can go to ~rvrpci.vnc X startup, you want to copy that and put that in your .vnc X startup. What this does is it tells you what window manager gets used. Okay. So I use here the FVWM, which is a very old window manager, but it's workable. Depending on your installation, some places you can actually start the GNOME browser or KDE. If you are familiar with those in Linux, you can actually start different types of window managers. But this is something that I forgot to talk about. But what you need to do is you need to tell it what window manager to start. And the window manager is specified by the user bin FVWM. WM stands for window manager. I can't remember what FV stands for, but you need to do that in your situation. So. I'm trying to think if there's anything else that you need to know. This is the one. This is the one where most people run into issues because the window manager is dictated by the system administrator what's available and where it's located. So you have to. This will get executed when you start up the VNC server, and it'll go through all of this. There's a bunch of those things. I have no idea what's going on there. The one thing that I do know is that you're starting up an Xterm window with the Xterm command here, and you're starting up the window manager. So for those of you who did a Xsigwin, it's sort of similar in that it's starting up a window manager on your machine, on your laptop, on your local laptop. Okay.
How do I copy this?
For me, so you would say CP, and then you would say CP RVRPCI / .vnc .x startup, and then you would put it in your .vnc. Okay. So you would copy that. It should be relatively. Yeah, if you type that command, that should copy that directly into your home directory, into your not home directory, but into your .vnc file. Okay. Again, with hidden files, in order for you to see them, you have to do an ls-a. The -a will show hidden files in this situation. Okay. It can't find the file. X startup. I don't have. Oh, let me just check my permissions. In fact, this might be a good time to talk about permissions also. What's that?
I was able to copy it.
Oh, you were able to copy it. So CP tilde RVRPCI .vnc X startup, and then you should.
When I did it, I just did /CIS/that.
Okay.
So I did like CP/CIS/that.
Okay, you didn't use the tilde. What? Let me see what the. Oh, you don't need that because it's implied that you. Correct. When you put the tilde / and then your username, it's looking for a directory under your home directory. Okay, and that's why I said a lot of people. The thing that people get messed up with Unix is the relationship of your home directory with other directories. So the tilde by default is your home directory. Right. So does that Colin? Does that help with the?
Yeah, dude.
So those are the kinds of things that if you guys have, I mean, I have other material to go through also, but if there's specific things that you find that you need to know right away, I can try to cover those, slip those into the lecture as well as work that in. Okay, so I think that's all I have for today. Bunny, it's not working as well as I'd like to. A lot of silly things that I said there, but and we'll